All right, guys, so this is our group project. We're going to evaluate a dietary guideline talking about sodium. I'm going to share my screen then so we can look at our presentation. Everyone seeing this okay?
Mm-hmm.
Awesome. So we're going to talk about sodium. Quick review about sodium would be discussing its metabolism and fluid regulation within the body and what it is. So sodium is an essential nutrient, a mineral required by the body for fluid balance. And that happens in part, one of the mechanisms is our sodium potassium pump for the electric gradient on our cells, which is important for our resting potential. That happens with the magnesium ion dependent sodium potassium ATPase. And I think that's interesting because we see another nutrient already, or two nutrients, the potassium and the magnesium being important. Sodium's excreted through our small intestine, absorbed in our small intestine and excreted through our kidneys through three different mechanisms. There's a vasopressin, renin-angiotensin aldosterone system, and a natriuretic system that all contribute to that. And we also see loss of sodium through the skin, sweating, and through the feces. So there's just a lot of fluctuation I see with sodium in and out of the body. And then calcium also plays an important role. And I found some of the research on that, but Devin, I know you had more on it. So if you want to talk about, oh, come on. I'm sorry, guys. There we go. Calcium, Devin.
No, that's fine. So, so calcium is found within the cells, bound within organelles. One thing I found about calcium, as I thought was really interesting, is the free calcium compared to the bound calcium. There's a 10,000-fold chemical gradient across the cell membranes, which means that there's a lot of work, I would think, that has to be done in order to keep that gradient the way that it is, because that's a pretty significant difference. So, I guess why are we bringing up calcium in relationship to sodium? So individuals consuming high amounts of sodium chloride could fall into some of the highest or the lowest blood pressure groups, depending on whether or not they're consuming enough calcium. That's what some of the studies found that we had read for this assignment. So higher sodium chloride intake with adequate calcium and potassium intake was actually related to lower blood pressure. So it kind of sets the stage for what we're going to talk about throughout this whole presentation, that all of these minerals and their relationship to each other matter.
Mm-hmm. Awesome. Do you want your next slide?
Yeah, please.
Okay. It's on a delay. Okay, there we go.
So calcium is really important as a messenger in our body. You can see on the right, I grabbed one image from the Stepanek text where you can see in the kidney itself where sodium is important in regulating how calcium is moving through these membranes. So it's important in like the hormonal control of plasma calcium. So rise in free calcium where these regulations are not being upheld can lead to muscle contractions and secretion of certain neurotransmitters. So, muscle contractions can lead to, I would assume, the heart's a muscle, so that would be a problem. We know that high calcium is related to heart issues and acute heart issues. So could we postulate in conjunction with the articles presented that given high chemical gradient of calcium, the importance of sodium is in its regulation and the body's efficient ability to maintain sodium homeostasis, that dietary salt is really a beneficial thing, and we don't want to be telling people to limit it to what we may perceive as extreme levels. So I guess that would be a question I had.
Well, it's a really good segue for the guidelines that we have here. Michaela, you want to talk about these?
Yeah, so the current dietary guideline is saying that it's basically the upper limit of our sodium intake, or what it should be, and that's set at 2,300 milligrams. At the DRI is actually 1,800 milligrams. No, not 1,800. 800 milligrams lower than that at 1,500 milligrams. And then that lowers as you get older, like 50 to 70 is 1,300. And then 70 years and up, it goes down to 1,200 milligrams of sodium. But the average sodium intake is currently like 3,440 milligrams per day.
Mm-hmm.
And people think that's too high and it should be reduced.
Yeah, and so I think what's interesting is like how did we come up with that? Like why is this? So like how is this guideline determined? You all agree that like it stemmed out of finding a nutrient to kind of like villainize for cardiovascular disease. That was kind of like the reasoning behind it.
Right.
Yeah. Except it's more correlated with blood pressure, which is just one factor in cardiovascular disease. So these studies the guideline was created from studies that were done 20 years ago, and they were done through extreme manipulation to find results that they thought were applicable to the general population. So they pumped extreme amounts of sodium, they reduced renal mass, and then they just took all of that and like found some mice that were salt sensitive, which I know we want to bring up later with Marshela, but there was just this huge rush to judgment and to create a guideline in 1979. But again, it was just this isolated single nutrient, not considering nutrient interactions or effects of dietary patterns. So I think nutrient interactions sounds like the food matrix, right? Because I don't know how many, I mean, some people might do this, but I don't go around just like eating salt. No, I don't do that. What are the problems with all of that?
Yeah, so I won't read all of this, but there's critical information that was not known about the influence of sodium intake on blood pressure, and it includes the following. The studies weren't well done, as Courtney said, and there was lacking information about nutrient interaction, which we're talking about throughout this presentation. And then there's some myths that came about because of these studies. You know, there was assumptions that were made that sodium intake has increased so dramatically over the last 100 years that people consume way more sodium than they need or require. So there's many falsities out there regarding sodium that have taken hold, and we're seeing we see it in the dietary guidelines, like what people are told to eat in terms of salt, and whether or not that's good or bad, I guess, is what we're trying to determine here, good or bad.
If we want to figure out if it's good or bad, we should look at the science, right? Not just like our beliefs or anything like that. And it was really interesting. The Surgeon General came out with that guideline in 1979, and then just 5 years later, 1984, the National Heart, Lung, and Blood Institute they did the InterSalt trial, and it only lowered BP by 1 point. And that was with a huge reduction, 30 to 50%. Which, I mean, knowing the average intake is about that 3,400 and that the DRI is 1,500, that's what they did. And it just didn't produce a very large result, so I don't know that it's really the best answer. And I think it begs to question, what are the other nutrients? We're seeing the calcium, the potassium playing a role from our earlier slides. And then again, 1999, that same institute, I'm sorry, my cat's that same institute found that sodium restrictions didn't benefit cardiovascular disease. It might have affected blood pressure, but not cardiovascular disease itself. And there just didn't seem to be much of an identifiable benefit to that in relation to cardiovascular mortality. That's just the science behind why this guideline may not be the best.
Yeah, so the salt sensitivity was something that one of the articles had presented, and how meaningful this is, I don't know, but I think we could, Marshela and I were talking about anecdotally how, like, her father, when he eats too much salt, he sweats. If I eat too much salt, I can feel it the next day. Like, I have water retention. So I think salt sensitivity is a thing. I think that the individual, I think we need to take it into account. Like, I have here this picture of the sodium potassium pump, and could we postulate that somebody may have a genetic transcription that disallows for this pump to work properly, and then maybe, like me, they retain water. I don't know, but I think it's something that we need to remember when we're talking about what we recommend people to be intaking in terms of salt. And I think we've said it before in this class, like, if you know that it doesn't make you feel good, maybe don't do it.
Yeah. Right.
Yeah, so that goes into like the interindividuality, and what works for one person may not work for another. So like this guideline, and it's basically for the general population. It's like a one size fits all, and they're trying to find the culprit of these diseases. Like, there was this one study, and it was based off of a study done with a community, and they were eating 5 grams of sodium per day, and they had higher rates of cardiovascular disease and stroke. So they just wanted to blame it on sodium, and it's like, well, you can't do that. Not everybody's eating that much sodium.
Yeah.
Right. And then that goes into adequate consumption of like all essential nutrients. And you can't just focus on just one, but we'll get into that later again. But potassium restriction induces salt sensitivity. So it's like, if you're deficient in some of these other nutrients, you're going to have sensitivities with others, because it all ties together.
I was thinking
that, like, with our world, we're really not looking at deficiencies more as like we're looking at people that are having an overabundance of things.
Right?
Yeah,
like 5 grams. I'm
thinking that in so much more potassium and so much more calcium, you need probably more sodium.
Right.
That's fair. Yeah, and I'm also thinking, like, if they're going to associate 5 grams of salt in a day, 5,000 milligrams, right? Then how are you consuming that? What are the foods that's found in? Like, it's usually processed meats and things like that. So, like, it may not be, again, the isolated salt that's causing their cardiovascular disease. It's probably the mixed meal that it's coming in. And then this next slide, Marshayla, reiterates what you were just bringing up, the nutrient interactions, and like, or I guess we were all bringing it up.
Yeah.
Devin was bringing it up too. The potassium, the calcium. Did you have any thoughts on that one?
I'll talk about the rat study. So there was a study done with salt-sensitive rats, and it came up with the results of being salt-sensitive emerged with disturbances in calcium homeostasis and induce calciuresis, which Devin was talking about earlier, and they wanted to indicate that sodium chloride raises blood pressure. And then with the potassium, as I just said, that if you're restricting that, then you're going to have salt sensitivity, because potassium and sodium, they like basically balance each other out. You can't have too much of one and none of the other.
Right. Okay. Let's see. So then, considering all of this, guys, we have this slide on, it came from the Should We Shake It Up article, and it discussed what goes into making a public health policy, and you need to have yes to these 5 questions presented here. Is it beneficial for most of the population? Is it significant benefit? Is it the most effective goal? Is it safe? And no, we find like that lower salt, too low of salt isn't safe, because we need it for proper function. It's an essential nutrient, right? So what our take on that sodium guideline then? It's that what we've been saying is the interindividual variability kind of needs to be considered your background, maybe your family history. If like someone else is known for the salt sensitivity, you can check out what's going on with you, what makes you feel good. Your thoughts, guys?
No.
Yeah. Inter-individual variation definitely would play a part in like these guidelines. You can't just do like a one size fits all approach, especially when it comes to people's diets. People don't have the same diet. You can't,
Mm-hmm.
so that definitely plays a part, and as well as the connectedness of the nutrients and the roles that they play together. You can't just pick out one nutrient.
No.
Like these guidelines, they must be like science-based. You have to like base it on science and not just assumptions or these studies where they manipulated them.
Right. That's awesome. All right, guys. That's 15 minutes. So just show this real quick if it'll change for me or not. I wanted to do citations. Ta-da! Okay. I'm going to somehow stop sharing my screen. I'm still recording, but I'll stop this now.